For number 17, on page 383, you're oxidizing NO. Oxidize means to react with oxygen. It is producing NO2. To balance the equation, we will need we are given 499 cubic centimeters. We're asked to find how much oxygen we will need. The overall pattern for all these problems are the same. First, convert your known to moles of known. You can do that using PV equals nRT. The problem tells us that we are at STP. So you can use PV equals nRT to get it to moles. However, that wouldn't be the quickest way, considering that you can use the molar volume, because you are at STP. Therefore, the molar volume is 22.4 liters for every 1 mole. Converted to liters. Every 22.4 liters, 1 mole. After you have your moles of known, you want to convert to moles of unknown. You do this using the molar ratio. For every 2 of these, I get 1 of those. Now to convert it back to volume, I once again use the molar volume. With 3 sig figs, my answer comes out to be 0.250. Remember, the molar volume you can only use while at STP. Now, when looking at this problem, you may have noticed that this and this cancel each other out. So there's even a shorter method. If the temperature and pressure do not change in the problem, and let me say that again. If the temperature and pressure do not change in the problem, then you can just use the molar ratios, because those 2 things will cancel out. So in the back of the book, you see just this. So you can do that as long as the temperature and pressure do not change in the problem. Therefore, with number 18, if you read number 18, it doesn't tell you that you're at STP. However, it tells you that the temperature and pressure do not change. Therefore, with number 18, we are asked to find the amount of hydrogen produced. However, they do not tell us the temperature and pressure, but they do tell us the temperature and pressure do not change. And if the temperature and pressure do not change, then you could just use the mole ratio. Number 20, you are asked to calculate the volume of carbon monoxide. It is a limiting reagent problem. We are at STP. All these problems follow the same pattern. Get it into moles. The molar mass of calcium phosphate is 360. Then I use the mole ratio, 2 to 10. At this point, the fastest way to convert it to volume will be to use the molar mass. I mean the molar volume. And you get 1.29 liters or decimeters cubed. Now, because it's a limiting reactant problem, we have to do the same thing with the other substance. If the problem wasn't at STP, then at this point you would have to stop and use
Campbell,
paper.
stop in the K office. Miss Campbell, please stop in the K-Wing office.
You'd have to use PV equals nRT to find your volume. But because we are at STP, then we can go and use the molar volume to convert it to liters. The smaller number is a limiting reactant. That is our answer. And that means we will run out of the silicon dioxide. For number 21,
What?
you are doing the same thing as in number 20. But this time you're going to be doing the molar volume at the beginning of the problem as opposed to the end of the problem. So, if we were at if you were at a different temperature and pressure, then you would have to use PV equals nRT. But because we are at STP, we can just use the molar volume. For every one of these, we get one of these. Then we do the same thing with the other problem. Iodine weighs 127 times 2. The ratio is also 1 to 1. The smaller one is our limiting reactant, and therefore we'll run out of the H2S first.